Okay, let's look at some graphs of sine and cosine, specifically with amplitude changes. Okay, for all of these graphs, I'm going to go ahead and just maybe mark out the x-axis like we did on the first two. I'm going to go ahead and just go every two lines, so that's out to 2 pi and to negative 2 pi. So let's just do that real quick. It's really, though, not enough to just put the little tick marks there. You need to label the axis. Okay, one more. Okay. And then, of course, if I don't label them, we'll just assume that every box counts 1. Okay. So, graphing with amplitude change. The number that multiplies the trig function. Okay, the 3 is multiplying the trig function. That is always where you're going to find your amplitude. The amplitude in this graph is 3. You can think of it in terms of stretching and shrinking the graph. This is so that's outside the function. This would be inside. This is outside the function. Kind of what we're looking at here is 3 times f of x. It has the effect of stretching the graph 3 times as tall vertically. So its points are going to plot like this. Actually, let me even plot one other thing here real fast. The normal sine graph would look like this. Start at 0, go up 1, back to 0, down 1, and then back to 0. Just so you can kind of see the change here. So that's what a sine wave would typically look like. This one's going to start at the origin, and then when it normally goes up 1, it's going to stretch up its amplitude value to 3. Come back to 0. It's going to stretch down its amplitude value and back to 0. That's the effect of the 3. It has just vertically stretched the graph. So as I continue the pattern this way, it's going to come down 3, back to 0, up 3 to there, back to 0. Of course, let's show that this keeps going. Ignore that point. Okay, the cosine graph. Let's do it this time. I'll do it without drawing the dotted line, the original graph in there. Cosine normally starts up at 1. Well, this one has an amplitude of 1.5. So instead of starting up 1, it's going to start up 1.5. And then its pattern is that it goes back to 0, and it goes down its amplitude, back to 0, and up its amplitude. It's going to kind of look like that. Continue this way, back to 0, down its amp, up to 0, up its amplitude. And there's our graph. Essentially the same graph we drew on the cosine graph before, except it's gone up and down 1.5 instead of 1 unit. The next one, -4 sine. Here, the amp is 4. Okay, it's not -4. We said before that the amplitude is always going to be positive because it's a distance, kind of like a height. The negative, it flips the graph or reflects it vertically. So instead of, we're going to start at 0, 0 still, instead of going up its amplitude to 4, like this one went up to 3 first, this one's going to reflect, it's going to go down to 4. And then it's going to come up to 0, and it's going to go up to 4, and back down to 0. Kind of like this. Pattern it on the other side. Oops, that should curve more. try not to make your lines sharp, angled, straight lines. They are curved lines. Okay, and finally a negative one for cosine. Again, its amplitude is 2. The negative flips the graph over. So let's see, cosine normally starts up at 1. This one, its amplitude would make it go up to 2, but it's going to start down here because it's going to reflect. It's going to go up to 0, up 2, back to 0, down 2. Same thing on the other side. So in the end, the graph's going to kind of look like this. Okay. So that's amplitude change, just stretching the graph. Of course, if the numbers were small, like a half or a fourth, it could just shrink the graph too. But basically, that's the value. You go up and down, above and below the x-axis. Okay, now let's look at a couple graphs that have both amplitude and period changes. Let's go ahead and mark the x-axis as normal, the way we've been doing it. I'm going to even throw a couple more in there. Okay, and just so, because I want to see like a visual comparison, I'm going to go and just put your basic sine graph in there. Sine graph starts at the origin, goes up 1, back to 0, down 1, back to 0. We'll just go ahead and get it this way too. So here's our sine graph. Okay, I just want to be able to compare how this one looks different than just kind of your basic y equals sine x. Okay, so what do we know about this graph? It has an amplitude of 3. So this one's going to be stretched up 3, down 3. We're going to just pull everything out 3 units vertically. For the period, the period is affected by this number here. It multiplies inside the function. The way we find the period is we take the original period, which is 2 pi. Okay, that's the original period length right here before it repeats. And we're going to divide it by whatever number is in front of the x. 2 pi divided by 2 reduces down to pi. That should kind of make sense. If you recall, we had talked about at length when we talk about transformations of functions that bigger numbers in front of the function make the function bigger. They actually stretch. Numbers larger than 1 inside the function do the exact opposite. Instead of stretching it, it's going to shrink it, right? And if you've got a 2 there, it's going to shrink it by the reciprocal factor. It's going to shrink it half its normal length. So instead of normally the period being 2 pi units long, it's going to be just pi units long instead. So what I want to do is see this entire wave instead of going from 0 to 2 pi, but compressed so it's between 0 and pi. Okay, how to do that? If you notice before, we plotted 1, 2, 3, 4, 5 points. Okay, which so to get 5 points from 0 to pi, I'm going to have to plot them at every tick mark. So I've got the first point at 0, 0. The next point is here. I'm going back to 0. I'm coming down my amplitude and back to 0. And here's how different it looks. Not only is it stretched, but it's compressed horizontally. And I could get another period length this way if we just continue. And it just keeps going. We could of course go this way also. And our graph will look like this. So the 3 stretches it vertically, the 2 compresses it horizontally, changes its period length. Okay. Let's do one more. Again, I'm going to do the same thing. I'm going to mark up my axis the same. So there's pi over 2, there's pi, 3 pi over 2, there's 2 pi. Same thing this way. And I'm going to go ahead and put on here just the original cosine x. Starts up 1 off the origin, comes down to 0, down 1, back up to 0, and up 1. Same thing over here. Okay, so the original cosine graph kind of looks like this. Okay. Now let's do this graph so we can again compare the differences between them, how they look different. The amplitude is 2. I will note that this one is going to flip vertically. That's what the negative is going to do. The period length, we take 2 pi, the original period length, and we divide it by a half. Half being the number in front of the x here. So the period length is 4 pi. It's actually longer this time than 2 pi. And again, that makes sense if we think of what we know about transformations. The smaller numbers here, so half, smaller than 1, smaller numbers make it bigger. Okay. So how do we actually plot that point? Let's think about it. Let's think about our x-axis and what that would look like. Okay, so when I mark this out originally, it is starting at 0, I go 1, 2, 3, 4 tick marks out, and that's the end of my period length. So let's do that. 1, 2, 3, 4 out. That should be where 4 pi is. Okay, if that's 4 pi, then that makes this 2 pi. If that's 2 pi, half of that makes that 1 pi, makes that 3 pi. So what I'm going to try and draw is a graph that looks like this. It starts up here, then it comes down, then it comes down, then it goes up, it goes up. So this is kind of what I'm trying to draw on this graph. Okay, but most important, what I'm trying to make sure that we see is these are the x values where I'm plotting points, at least the ones that fit on my graph as I have it set up. So the first point at 0 here is going to go to its amplitude 2, but it's going to reflect, it's going to be down here. Okay. Next point goes all the way out to pi, and it should return to the x-axis at pi. Okay. Next point is at 2 pi, and originally it's going to be down, but we're reflecting, so it's going to be above. So 2 pi, it's up here. We're off my graph now, but next would come back down, and then would come down some more, so it's kind of curving like this, which means if I'm going to curve it back this way, it's going to come up to 0 and up to 2 on this side. So there's my graph on the same scale that we're seeing just the original function. Again, I want the same scale so you can kind of see the differences between the two functions and what they look like.